Welcome you to the 11th practical of EE4183 Laboratory Practice 5 module, Study on Current Transformers. In this practical, we are going to learn about operating principle of current transformer, importance of polarity check, magnetization curve of current transformers, and burden of a current transformer. And we are going to observe the procedure of the practical. So let's move on to the basic theory part of the practical. You have completed your industrial training module. There you visited switchyards of grid substations and power stations. Now go back to that nice memory. There you saw current transformers. Current transformers, simply referred as CT, is a current stepping down transformer most of time. We can find out these current transformers from switchyards to clip-on ammeter in many electrical applications. Industrial current transformers step down the current so that power meters measure the currents and give the signals to relays to operate. Let's go inside to the city and see the basic operation. A conductor carrying a current goes through a hollow iron core. When a current flows through this conductor, a secondary current induces in the winding of hollow core. So this is simply a transformer. We can use transformer equations. So we know IP over IS is equal to NS over NP, where NS is the number of turns in secondary winding and NP is the number of turns in primary winding. But here NP is 1. Therefore, ratio between primary current and secondary current is equal to NS, which means primary current has been reduced by Ns times when it goes to secondary current. It is very important to observe the correct polarity when installing and connecting CT to power meters and protective relays. To check the polarity, let's recall the dot notation. You can see two dots in two windings. This refers if current flows in to the side of one dot, then the other dot refers that current flows out of the side of that dot. So now you see a three-phase delta star transformer and three current transformers are connected to each phase in secondary side. Also you can see the polarity of CT. If primary winding dot refers current in, then according to dot notation, secondary side dot shows current out. The CTs are connected to relays and relays are operated to unidirectional current. If we connect CTs with incorrect polarity, the relays will not work because of the false direction of current. Therefore, we should concern about polarity. The magnetization curve is a very important factor for a current transformer. You can observe the knee point of magnetization curve. After or beyond this knee point voltage, the linearity between primary and secondary circuits, that is, the desired property of CT, does not work anymore. Therefore, we should operate the CT in the linear region of magnetization curve. Burden is also a significant measure in current transformers. Burden means the total load connected to the secondary side of the CT. This will be the resistance of CT secondary winding, connecting leads, relays, meters, etc. Higher value of burden extends the saturation characteristics of CT core, and therefore during a fault current it may increase to a higher value. This is the significance of burden. The burden is measured in volt amperes VA, since this secondary load can be not only resistive. So why is it called in this name burden? The reason is, in a CT, the secondary cannot be kept open due to induced high voltage. So unlike normal transformers, the CT should be loaded always. So is it not a burden? Let's move on to the procedure. In this practical, we need this equipment: a wound type CT, a ring type CT, a clip-on ammeter. All these three equipment are CTs. Also we need a voltmeter, ammeter and a galvanometer. Then we need a current injector, which is simply a current step-up transformer. We can go up to 100 amperes current by using this. Then we need a 6 ohms resistor and a switch. We use this type of switch since we have to deal with high currents around 50 amperes. Finally, we need a variac, adjustable DC power supply and AC power supply. First, let's familiarize with CT. You can observe the nameplates of wound type and ring type CTs. Write down the details on the nameplates in your observations sheet. Then, let's measure the secondary winding resistance of CTs. You can use the multimeter to measure the resistance. Write down the reading in your observations sheet. Then, as the same way, measure the secondary resistance of wound type CT. Write down the reading in your observations sheet. Then we are moving to polarity check. As you can see in the circuit diagram, the negative terminal of DC supply is connected to the resistor. The other terminal of resistor is connected to the conductor, which goes through the hollow core of ring type CT. This conductor is the primary winding of CT. Then this conductor is connected to the switch, and then it goes to the positive terminal of DC supply. A galvanometer is connected to the secondary terminals of ring type CT to check the direction of secondary induced current. Now, let's check the polarity. First, switch on the DC supply and make the voltage as 5 volts. Then, turn on and off the switch quickly. Observe the deflections of the galvanometer at both cases, so you know the directions of primary and secondary currents. The primary current flowed to this direction and the secondary current flowed to this direction. So the polarity of CT as follows. Hope you understand clearly. Next part is ratio check. In this part, we need to pass a current of 50 amperes through primary winding, which is the conductor through CT. To have this 50 amperes, we need a current injector. This is a current stepping up transformer. Here we have primary winding terminals. In secondary winding, we have to select the current rating of what we want. There are 10 amperes, 25 amperes, 50 amperes, 100 amperes and 200 amperes. If you connect the conductor to the 50 ampere terminal, then maximum current that the terminal can pass is 50 amperes. So here we will select 100 amperes terminal for safety and the other secondary terminal, and keep this switch always open. Now let's see the circuit arrangement. As shown in the circuit, here the variac is connected to the 6 ohms resistor and the input terminals of current injector. One output terminal of current injector is connected to the switch by the conductor which goes through CT. Here we are using a thick wire since we have to pass a 50 ampere current. The current through this conductor, which is the primary winding of CT, is measured by a clip-on ammeter, and another ammeter is connected to secondary terminals of CT. Let's check the turns ratio. First, turn on the circuit and then keep this switch open and keep this switch closed. and then rotate the variac knob until the primary winding current gets 50 amperes. Now the primary winding current is 50 amperes, and then take the reading of ammeter which is connected to the secondary windings of CT, and then write it in your observations sheet. Then rotate the variac knob to 0 and then turn off the circuit. Then you have to calculate the turns ratio. So the primary winding current is 50 amperes and you know the secondary winding current as well. Therefore, the turns ratio will be primary winding current over secondary winding current. So you can calculate the turns ratio and write it down in your observations sheet. Now, we are moving to burden calculation since we have the same circuit arrangement as in previous step. So here you have the clip-on ammeter, and the current injector. The only difference in this part is that we are connecting a resistor to the secondary side of ring type CT. Here you can see the burden resistor. Then we measure the current through resistor and voltage across resistor. You can refer the circuit diagram to understand the connections. Now, turn on the circuit and then keep that switch open, and this switch should be closed, and then as in the previous step, rotate the dial so that we have a primary current of 50 amperes. And then take the readings of ammeter and voltmeter and write down in your observations sheet. Then we are moving to magnetization curves part. Magnetization curve shows the relationship between secondary voltage and current of CT. Therefore, here we take the readings for them. Now, let's see the circuit arrangement. First, let's take ring type CT. One terminal of variac output is connected to the resistor and the resistor is connected to the ammeter. Ammeter is connected to CT secondary windings through the switch. Voltmeter measures secondary side voltage. Now, let's take readings for magnetization curve of ring type CT. First, power on the circuit and rotate the variac dial until the voltmeter reading shows 5 volts. Then, take the ammeter reading. Then, increase the voltage by 2 volts and take the ammeter reading. Then increase the voltage by another 2 volts and take the ammeter reading. Likewise, increase the voltage 2 by 2 volts and take ammeter readings up to 20 volts. Then the next part. Now we have connected both type CT's secondary terminals instead of ring type CT. The rest of circuit is same as shown in the circuit diagram. Now let's take readings. First, power on the circuit and rotate the variac dial until the voltmeter reading shows 5 volts. And then take the ammeter reading as in the previous step. Then increase the voltage by 2 volts and take the ammeter reading. Likewise, increase the voltage 2 by 2 volts and take ammeter readings up to 20 volts. These are the readings obtained from the previous part. Then obtain the magnetization curves for 2 transformers. Then for calculations, determine the knee point voltages of 2 magnetization curves and calculate the burden of current transformer. For discussion, answer the following questions. So we have come to the end of the practical. Hope you enjoyed and gained knowledge from this video. Thanks for watching.